ISRO has been sending rockets into the space. ACE Academy has been sending engineers into various IITs, PSUs, prestigious organizations like ISRO, BARC, DRDO. In this ACE ISRO series, I am going to discuss typical questions that will help you in your preparation for various exams like ISRO, BARC and GATE examination. Before I take those questions, let me talk about the syllabus and its weightage. So have a look at the syllabus. If you are writing ISRO exam, there is no specific syllabus. So from various years, the GATE syllabus has been the reference. So if you look at this, engineering mathematics syllabus for computer science GATE, we have these three topics: linear algebra, probability statistics and calculus. So in ISRO, you can expect 3 questions from engineering mathematics. In GATE, you can expect 8 to 9 marks out of 100 marks. Now, engineering mathematics is a common subject for various branches. So you take computer science, you take electronics and communication, electrical engineering, civil engineering, mechanical engineering. So this session is also useful for other branch students who are preparing for exams like ISRO, BARC, GATE and so on. So for other branches, you have got few more syllabus from engineering mathematics. This syllabus is only for computer science, but this is also common for you. So now what I am going to do is, I am going to take some typical questions that will definitely help in your preparation. So let's look at this question. If M is an arbitrary real n cross n matrix, then which of the following matrices will have non-negative eigenvalues? So he says that M is a real n cross n matrix. Which of the following will have non-negative eigenvalues? What do you mean by non-negative? Non-negative means which is not negative. So there are various options like M square, M transpose whole square, M into M transpose into M. Now in the options, see here, the eigenvalues of M and M transpose are same. Eigenvalues of M and M transpose are same. So in the same way, there will be a similarity between A and D. In the same way, there is a link between B and C. So let us discuss this. So what I will do is, I will start like this. Let us go for a verification here. So what kind of verification? Let me consider a M to be a 4 cross 4 real matrix. Let us say its eigenvalues are like this: 1, minus I and I. Since it is real, so if you say I is one of the eigenvalue, minus I is the other eigenvalue. Now he just said real, he did not say symmetric, he just said real. So if you have a real matrix, its eigenvalues can be complex like this. Now why did I take like this? Let us see what are the eigenvalues of M square. What are the eigenvalues of M square? We know from the properties of eigenvalues that if lambda is eigenvalue of M, then lambda square is eigenvalue of M square. So what would be the eigenvalues? It would be like this: 1 square, minus 1 square and then minus I square, I square. So how much is this? This is 1, this is also 1 and minus whole square is anyway 1, but I square is there. So this is minus 1, this is also minus 1. So look at this. I have taken these as eigenvalues, but M square eigenvalues are negative. M square eigenvalues are negative. So option A is eliminated. In the same way, option D is also eliminated because M and M transpose have same eigenvalues. So this is also eliminated. So what next? You are left with B and C. Let's analyze. So before I analyze, let me show you one silly thing here. So let's take a matrix, let's say C equal to M transpose into M. Let's take C equal to M transpose into M. Let's take transpose on both sides. So what is C transpose? C transpose is M transpose M whole transpose. So if you simplify this, you get M transpose and then M transpose whole transpose. So this is again like M transpose into M. Look, we took C as M transpose into M. We got C transpose as M transpose M. So what's the conclusion? The conclusion is that C is equal to C transpose. So this is the first conclusion. C is equal to what? C transpose, meaning by the matrix that you have taken is symmetric. If M is a real matrix, for sure M transpose into M will be symmetric. So let's write like this. M transpose into M is symmetric. Symmetric matrix. So what next? Let me tell you something about positive semi-definite, because a lot of concepts, these are typical problems, not that easy problems. So what is a positive definite matrix? So this is one thing. We understood that M transpose M is a symmetric matrix. Okay. So this is the first conclusion. The second conclusion is, what is a positive semi-definite matrix? So let me put the heading as positive semi-definite matrix. So let's see what is this. Let's consider a vector like this, X, which is n cross 1. Let's consider a matrix like this, which is n cross n. What is X? It's a n cross 1 vector. A is a n cross n matrix. Now, what's the condition for a positive semi-definite matrix? So the condition is like this. X transpose A X is always greater than or equal to 0. X transpose AX. By the way, X transpose AX is a scalar. How do you know that? What is the order of X transpose? It is 1 cross n. What's the order of A? It is n cross n. What's the order of X? It is n cross 1. So if you multiply three matrices like this, the resultant matrix order would be 1 cross 1, which is simply a scalar. So if this condition satisfies, you can call such matrix A as positive semi-definite matrix. Now this is for all n cross 1 vectors X. For any n cross 1 vector X, you must get this greater than or equal to 0. That will be positive semi-definite matrix. So what next now? So the consequence of this is, if a matrix is positive semi-definite, all of its eigenvalues are non-negative. So the property of this positive definite is eigenvalues are non-negative. That means they are not negative, they cannot be negative. Either they are 0 or greater than 0. So you have to check this. So for the present problem, what I'll do is, so I have a matrix which is like M transpose M. I'll check whether this is positive semi-definite or not. So how do you check that? Let's write like this, X transpose. What is that matrix? It is M transpose M into X. This, if it is greater than or equal to 0, then it's a positive semi-definite matrix. All of its eigenvalues are non-negative. So how do you prove this? So this can be rewritten as Mx whole transpose into Mx. X transpose M transpose can be written as Mx whole transpose and then into Mx. So this is like a vector. When you take a vector, when you take a dot product of a vector with itself, you will get its magnitude square. When you take a dot product of a vector with itself, because this is like Mx transpose and then into Mx. When you take the dot product of a vector with itself, you get magnitude square. So magnitude square is always greater than or equal to 0. So you can rewrite this as, this is same as its magnitude whole square. So this is always greater than or equal to 0. Therefore, the conclusion is that this M transpose M is positive semi-definite. All of its eigenvalues are non-negative. So the answer is M transpose into M. In the same way, you can prove about M into M transpose. That means in the recent GATE 2023, there has been a multiple select question. Okay. So the answers for this question are B and C. M into M transpose M both have non-negative eigenvalues. Let's go to the next question. For the matrix A, which of the following statements is are true? So if you look at this is are, it means it's a multiple select question. He says Ax equal to B has a unique solution, Ax equal to B does not have a unique solution, A has 3 linearly independent eigenvectors, A is positive definite matrix. Okay. So now how do you solve this? Let's try to find its eigenvalues. So how do you find the eigenvalues? The procedure is you will get the characteristic equation. So what's the characteristic equation? It's determinant of A minus lambda I equal to 0. So come on, get that matrix. 1 minus lambda, minus 1, 0, minus 1, 2 minus lambda, and then minus 1, 0, minus 1, and then 1 minus lambda. So you need to find the determinant of this, equate the determinant to 0. So come on, let's find this. So 1 minus lambda into 2 minus lambda into 1 minus lambda, and then you have a minus 1, okay, and then plus 1 times minus 1 into 1 minus lambda, and then this is 0, so that's it, and then 0 times anything is 0, so equate this to 0. Do we have any common factors here? You have to do the simplification elegantly. So 1 minus lambda is common, so here also you have this 1 minus lambda. If you take 1 minus lambda out, let's see what is left. So you have this 2 minus lambda into 1 minus lambda minus 1, and then here if you take 1 minus lambda out, minus 1 is left over. So try to simplify this. This is anyway 1 minus lambda, so let's go to the next 1 minus lambda, and then try to expand this. So this is going to give you 2 minus 2 lambda, and then minus lambda plus lambda square, and then minus 2. Can you people type or can you people post the eigenvalues in the chat section? So into, yeah, this is 0. So what's happening here? This cancels. So you have 1 minus lambda into what? Lambda square minus 3 lambda equal to 0. So from this one can easily find the eigenvalues. So if you equate this factor to 0, you get lambda as 1. When you equate this, so this can again lambda can be taken out. So lambda into lambda minus 3, that means the other eigenvalue is 0 and the third one is 3. So these are the eigenvalues. With this you can comment about the answer. How? I'll show you. What kind of eigenvalues you have got? You got eigenvalues like 0, 1, 3. 0, 1, 3. We got 3 eigenvalues and all the 3 are distinct. Look at this statement. N distinct eigenvalues of a n cross n matrix will generate n linearly independent eigenvectors. If order of the matrix is 3 and you have got 3 distinct eigenvalues, that is going to generate 3 linearly independent eigenvectors. So is there any option like that? A has 3 linearly independent eigenvectors. So far, yes, option C is correct. And then he says A is positive definite matrix. Just now, few moments back, I said about positive semi-definite matrix. For a positive definite matrix, all the eigenvalues are positive. For positive semi-definite, all the eigenvalues are non-negative. But here, for positive definite, all eigenvalues are positive. Let's see. Here, the eigenvalues are 0, 1, 3. For a positive definite matrix, the eigenvalue cannot be 0. So this option is eliminated. What next? Ax equal to b has a unique solution, Ax equal to b does not have a unique solution. Now we have to decide that. That's also very simple. Can you people tell what is determinant of A? Can you put the answer in the chat box? What is determinant of A? Determinant of A is simply product of these eigenvalues. So 1 into 0 into 3, which is 0. Now whenever the determinant is 0, I can say that rank of A is less than its order. That is, rank of the given matrix is less than 3. Now with this you can comment about another option. Now when you say rank is less than 3, rank is less than 3, So what happens is you cannot get a unique solution, because for unique solutions you need rank of A exactly equal to n. But here rank is less than n, so you cannot have a unique solution. Is there any option like that? Ax equal to b does not have a unique solution. So this is the appropriate answer. So I can see that many concepts are linked in this particular question. So that's the standard here. So the correct answers are B and C. This is also a MSQ here. Okay, let's proceed to the next problem. Two vectors are given. One is 2103 transpose, 1012 transpose. Belong to the null space of a 4 cross 4 matrix of rank 2. Which one of the following vectors also belongs to the null space? And various options are given. Some students are new to the word null space. So let me explain you what does this null space mean. Let's first imagine a square matrix of order 4. Okay. So when he says 2103 transpose, what does it mean? It means the vector is like this, 2103. So let's take this as x, let's take this as y. So what is y? You need to take transpose of this, which is 1012. Okay, so this is y. He says that two vectors belong in the null space. You are all aware of the word null. Null refers to something called 0. So what do you mean by this two belong to the null space of this matrix? It means that if you consider a homogeneous system which is in the form of Ax equal to 0, so clearly when you substitute this x, when you multiply A with x, it is going to give you a 0 vector. That's the meaning of this. In the same way, y also belongs to the null space. So that means when you multiply A with y, what you get is 0. So when you say, or when someone says that this vector belongs to the null space, it means when you multiply A with x, you will get a 0 vector. When you multiply A with y, you get a 0 vector. So this information is given. Which one of the following vectors also belong to the null space? Now I have a silly question for you. That silly question is, you observe A, B, C, D. Observe them. Okay, simple observation. And you also observe x and y. This is x, this is y. Is there any option in which just by using x and y, just by adding them or subtracting them, just by taking a simple linear combination of x and y, can you figure out which option you have, or in simple words, by using x and y, can I generate any of these options? I'll be waiting for your reply in the chat box. What you are supposed to do is just observe these elements, observe this. Through some simple operations, can you get any of these options? So let's see whether you are able to answer or not. Bose, can you answer this? Manoj says D. Students, can you observe x and y? Okay, using x and y, can you generate any of these options A, B, C, D? Divya says that look at option A and she says go with x minus y. It's an excellent observation from Divya. She says that look, option A is created like this. It is simply x minus y, it seems. Acha? That means when I subtract this 2, am I getting this? Let me check. 2 minus 1, it's 1. 1 minus 0, it's 1. 0 minus 1, it's minus 1. 3 minus 2, it's 1. Yes, you are right. There is a simple observation. Okay. So now, will option A be the right answer? I will show you what to do next. So far what we have understood is option A is something like this. Option A is like this. So A into, so what is option A? Option A can be expressed as x minus y. So now you can multiply the matrices. you can write like this ax minus ay, but what we know is ax is a 0 vector because x is in the null space, ay is also a 0 vector, and 0 minus 0 is a big 0 vector again. So finally a into x minus y is also giving us 0. That means this particular vector will also be in the null space of the given matrix A. Look at the way they created. Even though you don't know what is null space, even then you can answer such questions. It is just a matter of simple observations, right? So I am very happy that some of you have understood that logic. Let's proceed. Now this is also one of the fantastic questions, and I am very sure this is going to help you, this will boost your preparation. Let the sets of eigenvalues and eigenvectors of a matrix B be lambda k where k is from 1 to n and vk where k is from 1 to n. What he is saying is there is a matrix B where lambda k are the eigenvalues and vk are the eigenvectors for the matrix B. For any invertible matrix P, the sets of eigenvalues and eigenvectors of the matrix A where B is P inverse AP respectively are. So what are they asking? They want you to find the eigenvalues and eigenvectors of the matrix A. They gave one relation between A and B. What is that relation? B is equal to P inverse AP. P equal to B inverse AP. So let's check that. So finally the question is about finding the eigenvalues and eigenvectors of the matrix A. So let's see what could be done. Okay. So again you need some common sense here. In the exam common sense is needed, that presence of mind is needed. Let's write some given data here. There is a matrix B whose eigenvalue is lambda k, eigenvector is vk. So you all know if lambda k and vk are the eigenpair, one can write like this: B into Vk is lambda k into Vk. Something like you people are used to Ax equal to lambda x. So let's put this information aside. Let's put this information aside. Now let's talk about A. What is A? I'm going to use this, okay, just keep in mind I'm going to use this information. So there is a data here that B is P inverse AP and they want the eigenvalues of A. So please remember, if they want the eigenvalues of A, like you have to do like this, whatever you do finally you must get an expression like this, something like Ax equal to lambda x form. Do whatever you want, but try to get an expression which is looking like Ax equal to lambda x. If you can get that expression Ax equal to lambda x, you can easily say that lambda is the eigenvalue of A, x is the eigenvector of A. So now what are you going to do? Somehow I need A into x, A into a vector equal to a scalar into the same vector. So how do you get that? For that what I will do is I will first remove this P inverse. How do you remove that P inverse? Let's multiply P like this. Let's multiply the matrix P on both sides. So you get PB equal to AP, because you all know P into P inverse AP na, but P into P inverse is identity matrix. So what you get is PB equal to AP. I hope this is clear so far. What next? Let's multiply Vk on both sides, where Vk is nothing but a vector. Let's multiply Vk. So this is like P B Vk equal to A P Vk. I have multiplied Vk on both sides. Now why don't you observe this term? This is BVK and BVK is also here. What would be the substitution for BVK? Now from this BVK is simply lambda k Vk. Okay. So let's go to the next page. So we have something like P into lambda k Vk equal to, so what's there? A. I can write this as P Vk. So we have almost got the answer. So what's happening here? Can I rewrite like this? Something like A into PVK equal to lambda k is a scalar, you can put that out, and then you have this PVK. That's it. We are done with the solution. Please understand, P is a matrix, yes, but Vk is a vector. When you multiply a matrix with a vector, you again get a vector. P is a matrix, Vk is a vector. When you multiply this, you get a vector. Now, this is in the form of A into X equal to lambda into X. Can you people compare and tell me, can you post your answer in the chat box? What could be the eigenvalue of A? What could be the eigenvector of A? Okay, so whoever answers, I'll read out their name. So please, can you, let's see, anyone? I'm waiting for your replies. From this, can you people tell what is the eigenvalue and what is the eigenvector of A? So far I have not received any answer. So let me just give you 20 more seconds. A little tricky question this is. Observe. Shyam says lambda k is the eigenvalue, PVK is the eigenvector, which is absolutely right. So let's see whether such option is there. PVK is a vector, lambda k is the eigenvalue. So is it okay? No, because lambda k into determinant of A is there. Here just Vk is there. PVK is there and lambda k is there. So the answer is option C. Okay. So again a fantastic problem. You need some common sense here. That's it. So these were the questions, typical questions that were asked in our recent gate. So this will definitely help you, give you some confidence. Now let's look at some typical ISRO questions, because you are all seriously preparing for the upcoming ISRO examination. So I have taken some typical questions. For the distributions given below, so there is a distribution A, there is a distribution B. So various values are given. For example, the observation 10 is repeating 5 times, the observation 20 is repeating 4 times, 30 is repeating 3 times, 40 is repeating 2 times, 50 is repeating once. In the same way, there is another distribution where the observation 10 is repeating once, the observation 20 is repeating 2 times, observation 30 is repeating 3 times, observation 40 is repeating 4 times, this one is repeating 5 times. So some data is given to us. What are they asking? Which of the following is correct for the above distributions? Various options are given. Standard deviation of A is significantly lower than standard deviation of B, right? So sigma A is less than sigma B, it's significantly lower. Option B, standard deviation of A is slightly lower than the standard deviation, maybe slightly he says, and here he says significantly. Okay, fine. Standard deviation of A is same as the standard deviation of B, and option D, standard deviation of A is significantly higher than the standard deviation of B. I will once again show you, this is the data. I want you people to comment the answer, and after that I will start my explanation. I will give you maybe 15-20 seconds time. Just look at this, and what are they asking? You need to compare the standard deviations of A and B, standard deviations. So once you try to recollect the definition of standard deviation. So let me see what are your answers. So far no one has answered. So let's wait for few more, 10 more seconds. I just want to know your opinion before I solve this. Divya, is option C your answer for the present question or previous? Yeah, I think Divya has answered. She says B is greater. That means she wants to say that standard deviation of B is greater than standard deviation of A. So that's what is answer. And another student also says greater is B. Okay. Now let's see what's happening here. If you look at this, the observation 10, first of all, do you know what is standard deviation? It actually gives you a measure of how the set of values are spread out from their average value. Okay, it gives you it's a measure of how the set of data values are spread out from their average value. Now let me show, this is 10 which is repeating 5 times, 20 repeating 4 times, 30 repeating 3 times. Now look at the way the observations are. Okay, these are decreasing, that's fine. So the way they are decreasing, in the same way they are also increasing here. Something like 10 is occurring 5 times, the next observation is decreased by 1, 1, 1, 1, so on. In the same way, the same pattern is also observed here. The observations, if you look, 10 is occurring once, 20 is occurring 2 times, and so on. So now, if you look at the variation is same. So what I feel is the standard deviation of A and standard deviation of B are exactly same. Okay, so if you don't believe my words, let's do some mathematics then. Let's do some mathematics. So let me show you what's happening here. So how do you find the standard deviation? If you look at the distribution A, so let's write x here. So the observations are 10, 20, 30, 40, 50. Their frequencies are 5, 4, 3, 2, 1. So let's write the frequencies. 5, 3, 2, 1. So these are the frequencies. Now how do you find the standard deviation? I will show you how to find that. First let's find the mean. Let's find the mean. So the mean is sum of observations by the number of observations. This observation is repeating 5 times. So I will say 5 into 10 plus 4 into 20 plus 3 into 30 plus 2 into 40 plus 1 into 50. And then you have this whole divided by 15. How 15? 5 plus 4, 9, 9 plus 3, 12, 12 plus 2, 14, 14 plus 1, 15. So let me take 10 out. If I take 10 out, so this is 5 plus 8 na, plus 9 plus 8 plus 5. So this is 13, 26, 26 plus 4, 30 and 5, 35, and then by 15. So you have something like 10 into 35 by 15, 5 3s are, 5 7s are, so it is 70 by 3. This is just the mean, Let's also find the mean of B, which is interesting. The mean, so they give some distribution. Let's write B, the distribution which is named as B. What are the observations? What are the observations? Again, 10, 20, 30, 40, 50 are the observations. What are their frequencies? Exactly in the reverse way. That is 1, 2, 3, 4, 5. Let's find the mean. What's the mean? It is 1 into 10 plus 2 into 20 plus 3 into 30 plus 4 into 40 plus 5 into 50 and then whole divided by 15 again. So you can take 10 out. If you take 10 out, what is left is 1 plus 4 plus 9 plus 16 plus 25 whole divided by 15. So how much is this? This is 5, 14, 14 plus 6, 20, 30, 30 and then 55. So this is 10 into 55 by 15, 5 3s are, 5 11s are, and this is 110 by 3. So now interestingly the mean is, one case it is 70 by 3, in other case it is 110 by 3. Now students like who have answered, like some students like Divya, Sham and another Bimzaz, they have answered that B is greater. Okay, but what we have calculated is mean. The mean of the distribution is 110 by 3 and the mean of this distribution is just 70 by 3. but they are not asking you the mean, they are asking you the standard deviation. So how do you find the standard deviation? So first find variance and then take its square root. So let's find, so this is the distribution A, let's find the variance. So what you are supposed to do is, you try to subtract the mean from every observation. So this observation 10 is repeating 5 times, so it is 5 into, let's subtract the mean, which is 70 by 3, and then you have to square it. Next, 20 is repeating 4 times, so it's 4 into 20 minus 70 by 3 whole square, plus next 3 into, the next observation is 30 minus 70 by 3 whole square, and then it's like this, 2 into, next observation is 40, so 40 minus 70 by 3 whole square, and then there is only one observation 50, so it's 50 minus 70 by 3 whole square, and in the denominator you will have 15. You need not find this actually, okay, just keep it as it is. So I am trying to say that don't get the numerical value, but simplify this. If you simplify, what happens? This 3 goes here, this is 30 minus 70, which is minus 40, but there is a square. So what you have is 5 into 40 by 3 whole square plus 4 into, come on, this is 60, and then minus 70, minus 10, but there is a square, so it's 10 by 3 whole square plus 3 into, this is 90 minus 70, 20, so this is 20 by 3 whole square, and then plus 2 into 120, 120 minus 70 is 50, so it's 50 by 3 whole square, and then 150 minus 70 is 80, so it is 1 times 80 by 3 whole square, and then you have in the denominator 15. Don't get a mathematical value, numerical value, just keep this as it is. When you are preparing, this is what you have to do, and in the exam, just by looking at the way this data is varying, you can answer it in a fraction of a second. But when you are preparing, you have to do this kind of preparation. Then, with this, your confidence will improve. What next? I would also like to find the variance of B. Come on. How do you find variance of B? So this is, you can write like this, 1 into 10, the mean is 110, okay, 110 by 3, and then you got a whole square, plus 2 into, next 20 minus 110 by 3 whole square, and then you have this 3 into 30 minus 110 by 3 whole square, and then 4 into 40 minus 110 by 3 whole square, and finally 5 into 1150 minus 110 by 3 whole square, and then again you will have in the denominator 15. Now quickly try to simplify this. So 30 minus 110 minus 80, but there is a whole square, so this is just 1 into 80 by 3 whole square. The same term 1 into 80 by 3 whole square is also sitting here, 1 into 80 by 3 whole square. You will see the same terms now, come on. This is 60, 60 minus 110 is minus 50, but there is a whole square, so you have 2 into 50 by 3 whole square. So what do you have in the previous expression? Same thing, 2 into 50 by 3 whole square, come on, plus this is 90 minus 20, minus 20 whole square is same as 20 by 3 whole square, correct? So 3 is multiplied to that. Where is 20 by 3? This is 20 by 3, and then 3 is multiplied to this. So you are getting the same sequence. Next, plus, what about this? This is 120, 120 minus 110 is 10, so 4 is multiplied. This is 120, yes, 4 into 10 whole square, 10 by 3 whole square. Do you have such term? 10 by 3 whole square, 4 is multiplied, and the final one, this is 150, 150 minus 110 is 40 by 3 whole square, 5 is multiplied. Yes, I got exactly same thing, 5 into 40 by 3 whole square, and in the denominator I have 15. Let's ask the students earlier who said greater than B or greater is B, right? Let's ask them what is the variance for both the distributions, and then what would be the relation between standard deviation of A and standard deviation of B. Let's ask them. Students, are you there? Can you answer me? What's the relation now? So far I have not got any answer. I'll wait for 10 seconds or 15 seconds because there would be a lag actually. Shyam says both same. He means to say that the standard deviation in A, means standard deviation of A and standard deviation of B are both same. Divya says the same thing. Ganesh also says the same thing. Okay. So what's the answer for this question? The answer is standard deviation of A is same as the standard deviation of B. So I hope you will definitely understand this. Look at this. This is just the mirror image of this. So why they are same is that because you are subtracting mean, okay. So you are subtracting the mean and then you are squaring. That's the reason why the standard deviations are same. I once again repeat this because this can be asked in many of your interviews. What does this variance or standard deviation give you? So they show you, or it's a measure of how set of data values are spread out from their average value, that is the mean value. This definition is very important. Let's take few more questions. If a program P calls two subprograms P1 and P2, and P1 can fail 50% of the time and P2 can fail 40% of the time, what is the failure rate of program P? Okay, so this was asked in ISRO 2013. He says that there is a program. So you are all, if you are computer science students, you write programs and you have some subprograms, you call some subprograms. Let's say this is your program P. So you are using a subprogram called P1 and another subprogram called P2. P1 fails 50% of the time, P2 fails 40% of the time. So we can, from this we can say that the probability of P1 fails, percentage is given. If you want to write in terms of probability, it is simply 0.5. The probability of the subprogram P2 failing is given as 40. So if you write it in probability, it's 0.4. So these are the two subprograms which are used in this program. What he wants finally is, what is the failure rate of the program P? So what's the failure rate of the program P? So how do you find this? So I want P failing. So what you can do is, you can use complement rule. So according to complement rule, you can say something like this. If you want P to fail, so you can say 1 minus P1 doesn't fail, okay. So P1 doesn't fail. So let's write like this, does not fail, intersection with P2 also does not fail, does not fail. Now since these two events are independent, because so both the subprograms are independent, you can assume that they are independent. So for independent events, the probability of their intersection is simply equal to product of individual probabilities. I once again repeat this. For independent events, the probability of their intersection is equal to product of individual probabilities. So this can now be written as 1 minus probability that P1 does not fail into probability that P2 does not fail. So do you have these values? The probability of P1 fails is 0.5. Now this is something which is complement to this. So 1 minus 0.5, which is 0.5. So I have this value. The probability of P2 does not fail. So probability of P2 fails is 0.4. So this is the complement of that. So 1 minus 0.4, which is 0.6. You can substitute them. So this is 1 minus 0.5 into this is 0.4, so 1 minus 0.4 is 0.6. Come on, simplify. This is 0.3, 1 minus 0.3 is 0.7. So the answer for this question is 0.7. Is that option there? So we got in terms of probability, but the options are in terms of percentages. So obviously it is 70%. Such simple questions have been asked. Now look at this. You would have solved this in your 11th, 12th standard as well. Okay. The probability that two friends are born in the same month is, probability that two friends are born in the same month. So what's the probability of a friend, like what's the probability of let's say what's the probability that you will be born in a particular month? So the probability of you born in a particular month is 1 by 12, but he says what's the probability that both friends are born in same month? So the two friends can take the birth in January, or they can, both of them can take a both can have the birth in February or March or and so on. Whenever you use the word or, addition comes into the picture. So both can be born in the January, February, March and so on. So I will show you what's the probability that both of them are in the same month, that is January. So since there are 12 months, the probability of being born in January month is 1 by 12. So the first friend in January month is 1 by 12. At the same time, the second friend should also be in the January month. So this is 1 by 12 into 1 by 12. This is just for January month. So they can also born in February month. Okay. So they can be like this. So it is 1 by 12 into 1 by 12. Now this is the probability of the first friend. This is the probability of the second friend. This is January month. This is February and so on up to what? December. So 1 by 12 into 1 by 12. So the same term is repeating 12 times. So you can write this as 12 into 1 by 12 into 1 by 12. So there is a cancellation and then the answer is 1 by 12. So some of you might be thinking, why did I write 1 by 12? The probability that I am born in the January month, because there are 12 months, and what's the probability that I will be born in the January month? They are all equally likely. So it's 1 by 12. And the same month the other friend should also take his birth. So it is 1 by 12 and so on. Such a simple question. So the final answer is 1 by 12. Let's go to the next problem. This I found very interesting. I want to interact with you people while solving this. First let me read the question. Let me take your opinions. So how, like what is your answer and so on. It says a bag contains 19 red balls and 19 black balls, and I am frankly telling you, when I have solved this for the first time, was unable to crack the logic, but I sat peacefully and then started the various possibilities. That's when I got the answer. Let's read this. A bag contains 19 red balls and 19 black balls. Two balls are removed at a time repeatedly. Two balls are removed at a time repeatedly and discarded if they are of same color. But if they are of different, black ball is discarded and red ball is returned into the bag. The probability that this process will terminate with one red ball is. Okay. So you can take some time, you can read the question, very interesting. You may not be able to crack this in the first attempt, but if you can spend some more time, 2-3 minutes more, and if you can list out the possibilities, you will definitely crack the problem. So let's see what students are commenting here. Somdeep Bose says 1 by 144 for the earlier problem. I hope Somdeep Bose has understood. Okay. So I'll give you 1 more minute time. You can go through this. A bag contains 19 red balls and 19 black balls. So let's write like this. 19 red, 19 black. Two balls are removed at a time repeatedly and discarded if they are of same color. He says every time he is picking two objects, it seems. If both are of same color, he will never put those objects again into the bag. Okay. For example, so 19 plus 19, that is 38. 38 objects are there. Let's say you have picked two items. If both are red, you will never put those two reds back into the, you will never put those red objects into the bag. Let's say you have picked two black objects, you will never put those black objects again into the bag. That's what is given. What if I pick a red black or a black red, that is if I pick objects of opposite color, what happens, or different colors? But if they are different, black ball is discarded and the red ball is returned into the bag. He says black object is discarded, it seems, and the red object is safely placed in the bag, it seems. Okay. The probability that this process will terminate with one red ball is. Okay. So just take your time. I'll be in, very much interested to read your opinions about this. Do you have any answers for this? You can take a minute time. So far no one has responded. Manoj, Somdeep Bose, Divya, Sham, and so on. Can you people reply about this? Fine. So let me explain you. I am expecting some answers from the students, okay. So he says 19 red, 19 black. So can I write the number 19 as 2 into 9 plus 1? 2 into 9 is 18, 18 plus 1 is 19. So this 19 red can be imagined as 2 into 9 plus 1 objects. Similarly the black. Now when you take two objects, what are the possibilities? The possibilities are both can be red, both can be black, it can be red black or a black red. Fine. According to this problem, if you take red red or black black, you will never put those objects again into the bag. But if you take red black or black red, the rule says, or the question says, that you will take this red, put it in the bag, but you will discard the black itself. That's the logic. So now what I'll do is, I'll start the question like this, some simple observations. I'm just trying, I'm not solving it analytically, I'm not proving anything, I'm just thinking what is going to happen if I do it like this. Let's say you are drawing two objects at a time. Let's say initially let me draw all the red objects and then I'll try to draw the black objects. You can also do this. Why only red? You can try all black objects first and then followed by the red objects. Or if you are not okay with that, you can draw one red, one black. But you start you start drawing them. That's when you get the idea. So let me start this. Let's say I have started. Now what I'm getting is all red. So first attempt I got two reds. Since if I get two reds, I discard them, so now 17 are left over. So this number will help you students. So I started picking them. So 9 times I repeated this experiment, 9 times. So 2 into 9, 18 red objects so far I have got. All those red objects are discarded because when you draw two objects of same color, you are discarding them. Okay, so all of these are discarded. So I have repeated this experiment 9 times. Now next only one red object and 19 black objects are there. Now I don't have a chance of picking two red because there is only one red available. So fine, one red and remaining 19. What I'll do is, again I'll start removing the black, only black. So two blacks, like that I'll repeat them 9 times. So by 9 more attempts, I would have removed 18 black. Since they are of same color, they are discarded. Now one red, one black is left over. So you are forcefully, you are forced to pick that. But when you pick one red, one black, since they are of opposite colors, you will discard black, you will place that red there. That means after this much of hard work, for sure there was a red object there. Look at my sentence. For sure there was a red object there. So what I am trying to say is, this process, the way they created the question, when you keep drawing them, for sure you will have one red object at the end. So when I say for sure, what do you think is the probability? So the probability is obviously 1. So because you repeat this any number of times, finally what is left over will be one red object. So the answer is option A. Let us say you do not agree with my explanation. You might say, sir, acha, are you a magician? Huh? Because every time you want to take 2 reds, you are picking randomly, na? So why you will get 2 reds? Okay, you can take whichever combination you want, but finally you will see one red at the end. Let us say you have done something like this. There are 19 red, 19 black. So what you are trying to say is, okay sir, earlier you picked 2 reds or 2 blacks, that is fine, we understood. What if I pick 1 red, 1 black? Okay, you do that. Let us say you started the experiment. So first attempt, you picked 1 red, so you picked like this, red and a black. So the moment you pick a red and black, that is, they are of different colors, you will discard this fellow. What you will do? You will discard this fellow, you will place this again into the back. So with this, what happens is, there would be 19 red and only 18 black. And you repeated this. Let us say again, 1 more red and then black. Okay, so you will discard black, but you will keep red inside, right? So like this, what happens is, all the black balls will be discarded. So finally, so every time you are, let us say you have repeated this multiple times, so what happens is, again you will have those 19 reds. When you have those 19 reds, again you repeat this, what happens is, for 9 more times you will remove all those reds and finally one red would be left over. You conduct this experiment in any way, finally what you will see is a one red object. So the answer for this fantastic problem is option A. Okay. So these are some of the typical questions that were asked in the ISRO examination or the typical problems in the GATE. I would like to give you one homework problem. You can post your answers in the chat. I will also provide you the solutions in the comment box. So there are 30 students, it seems, occupy a classroom containing 5 rows with 8 seats in each row. If the students sit themselves at random, the probability that 6th seat in the 5th row will be empty is dash. So total there are 30 students, there are 5 rows, it seems, okay, there are 5 rows, 1, 2, 3, 4, 5 rows, and every row has got 8 seats, so you can show them like this, 3, 4, 5, 6, 7, 8. It like this. So if this is the first row, then these are the seats, 1, 2, 3, 4, 5, 6, 7, 8, 8 seats are there. So total seats would be, come on, total seats would be, since 5 rows and each row 5 seats, 5 into 8 would be 40 seats, but there are only 30 students, more seats, less students. What he wants, 5th row, this is the 5th row, and the 6th seat, which is the 6th seat, 1, 2, 3, 4, 5, 6. He wants this seat to be empty. This seat to be empty. I will give you the hints and I will also provide you the answer in the comment box. He wants this seat to be empty. So how do you solve this? The total seats are 40, but there are only 30 students. Now in how many ways out of this 40 students, not 40 students, I am very sorry, out of the 40 seats, you have to select 30 seats because there are only 30 students. So the total cases students, total cases is 40 choose 30. Why? 40 seats, but there are only 30 students. So you want to choose only 30 seats out of those. So it can be done in 40 C 30. We got the denominator. You all know probability is the number of favorable cases by the number of total cases. So we got the denominator. Now I am going to give you an activity for you. Now leave this. This is, he said it has to be empty. Okay, this is empty. How many are left over? Okay, how many are left over? I will not tell you the answer because you people have to post that. How many are left over? Are total 40 and you are just removing this, so how many are left over? So there is that number, right? I don't want to reveal that number. So that is some number, but you have only 30 students. So in how many ways you can choose 30 students from the remaining seats? That is nothing but your favorable cases. And then your final answer would be favorable cases by the total number of cases, which I want you people to comment. So once again I will tell you, total 40 seats, you want this particular seat to be empty. So leave this, how many are left over? How many are left over? Out of that you just want 30 seats. So in how many ways you can select that? That is nothing but your favorable cases, and this is the total number of cases. So I hope this question series or our AS ISRO series is beneficial for you. Now let me also tell what AS offers you. So look at this. We have very few interesting things which will definitely help students who are preparing for the competitive exams. So these are our course details. We have offline classes, we conduct offline classes, we conduct online live classes, we also provide students with recorded classes. So in 3 modes we have been teaching, and you can also add our postal coaching as well. So we conduct online live, physical class, we provide the recorded content, and then postal coaching, and with the technology we are also clearing the doubts. So you see the instant messaging apps like WhatsApp, Telegram, the same way we have a instant messaging app called Fresh Chat. Okay, so in our AS online app there is an option called Ask an Expert. You can post your doubt there. Once you subscribe our course, there is an option called as an Ask an Expert where your doubt will be cleared in hours, something like within 1 hour or sometimes maybe 3-4 hours. So that's how we are working. So what I want to say is we are conducting physical classes, we have been providing online live, we are providing recorded classes, we are giving postal coaching to the students, interview guidance, we are also clearing those doubts. So we also conduct live doubt sessions. So this is about our program. Next, we have also launched something called as QRC, which stands for Quick Revision Course. So students who have already prepared, let's say you have prepared GATE few years back and you want to have a quick revision, or the students who are the college goers who don't have much time, or students who are employed who want to prepare who don't have much time, those students can take our quick revision course. So where look at this 250 plus hours, and we have this live doubt sessions, Ask an Expert facility is there, all our expert faculties. And then, so this is the quick revision course. We also provide, so this is the previous year questions. So we have recently launched this program where we provide the previous recorded solutions for our previous year questions. So it's a new program. This will definitely help the students. This particular PYQ course is launched for all the branches, not just computer science. It is launched for all the branches. So where we solve all the PYQs from GATE as well as ISRO examination. So you can use this because PYQ is the biggest resource for any exam preparation. Next, we have also this courses, recorded courses in Hindi. So we come with a tagline, अब तैयारी होगी आसान, पढ़ाई करो तो दिल से करो. So we have this tagline, पढ़ाई करो तो दिल से करो. So these are our course details. We also have an exclusive book which is ISRO previous year questions. So since our last exam is conducted 2020, we have from 2007 to 2020 all the questions along with the detailed solutions. So who are preparing for this, you can purchase this. This is available in the Amazon and the Flipkart. Even in our office centers we provide this. You have to purchase this. If you are interested, you can purchase this. This is again a very important resource for your preparation. Now This is a AS ISRO series. So we have series of live sessions coming up. So we started with, I think, programming language. So initially we had some orientation. So our Ramesh sir gave orientation about like how to prepare about this, what is the weightage for all the topics. So that was the orientation, and then we had the programming language and another, I think, data structures, I suppose, and this engineering mathematics. And next coming up is discrete mathematics. So this is on July 25th, 7 p.m. Okay. So this is what we have on the 25th July. I hope this session is helping you in your preparation. Thank you. ఎండ్ చేసేసారా? అయిపోయిందా? చాలా